Hello everyone, my name is Jaeho and I'm a part of the game Platform Dev 2 team. In this session, I'm going to talk about how we built the real-time targeting platform in the Line game platform and the problems we faced during development. The session will cover the general architecture of the platform. So I think it will be helpful for those of you who are either building a real-time targeting platform or someone who wants to know the things that need to be considered in building this platform. The subjects I'm going to go through in this session are the following. First, I'm going to talk about what motivated us to develop a real-time targeting platform. And before going into the real-time targeting platform, I'm going to explain the architecture of the log processing platform, which is operated by the Line game platform. And then I will go into an explanation about the real-time targeting platform. Then I will show some use cases and then share the issues that came up in the process of development. So the first subject, motivation. In the motivation section, I'm going to describe what real-time targeting is and what result you can get from using the real-time targeting platform. So first, a definition of what targeting is. Targeting refers to collecting information about users' persona, profile, behavior, and environment and creating a single context out of all of that information and providing a function suited to the context. The corresponding information could be basic information such as a person's nationality or their linguistic background, but it also could be deduced information such as person's preference or tendency and so on. For example, sending a push message to a user with a high bounce rate could also be viewed as targeting. Next, a definition of real-time. The term real-time from a development perspective is a vague term because it could mean different things to different people. For instance, for a DBA, receiving a result of a query within 2 milliseconds could be thought of as real-time, whereas for a user, if the page they are seeing can be fully loaded within 1 second, that could mean real-time for them. But there is one common factor in the definition of real-time, and that is the concept of a time limit or a threshold. This time limit differs according to the situation of each business or the goal of an application, but as long as a task can be completed within an expected time limit, then the task could have been said to have been done in real time. And therefore, a system that processes a request from a service or an application within the time threshold could be called a real-time system. Now, I'm going to explain the results you can achieve through real-time targeting. First, you can reduce noise. Here, noise also refers to the non-quantitative aspects, including the fatigueness and irritation a user feels. These non-quantitative aspects are usually not considered, but it could have a significant impact in the next promotion or other events that are carried out. For instance, if a push message is sent to a user who does not need to be notified, increasing their user fatigue, and the user decides to block messages, the user won't be able to receive a message about a promotion that could be in their interest. Second, you can reduce costs. When I say cost, I think the cost in sending out messages and server cost in carrying out promotions will easily come to mind as examples, but you also have to think about the losses incurred by paying for promotions. Let's say we showed a banner promoting item A, but user 1 was a user who needed item B. Here, by showing a banner for item A, an opportunity leading to a user's purchase action is lost. Using the real-time targeting platform, we can reduce this kind of cost by showing the right banner to the right user at the right time. In other words, through the two aspects that I have just mentioned, we can improve the performance of a promotion. In order to establish real-time targeting on the Line game platform, event processing architecture is applied. So in this section, I will briefly explain why this architecture was used. First, we have to know the definitions of log and event. So I will provide you with a simple definition of what we mean by log and event. Log refers to any messages you want to preserve for audit or for the system. Its priority is relatively low and it's usually used for audits. but could also be used for monitoring or debugging. Event is a part of the log, but some differences exist. First, event must be designed around goals. The things that you want to observe or monitor for business purposes are defined as events and collected. Second, if a log is data that simply piles up, an event could require an action to be performed, such as updating a user's status or so on. For instance, if I purchased item A, a follow-up action would be required that would actually place the purchased item in my mailbox. Third, in this way, since events could be accompanied by corresponding actions, it requires more detailed handling of transactions and losses. So I'm going to use 3 sets of keywords to explain why we implemented the event processing system. The first set of keywords is latency. In case of the existing batch processing system, jobs could be executed in minutes or sometimes in hours. This creates a discrepancy in the user state between the current status of the user compared to when the user targeting data was generated. The second set of keywords is filtering and validation. In the log processing system, its purpose was to simply collect logs for analyzing and processing. But in the event processing system, the collected data had to satisfy the requirements in order to be identified as an event, and we needed information to filter the logged data. The last set of keywords is windowing and aggregation processing. The conditions used to target users include profile information such as gender and age, but it also includes historical data and conditions that must be temporarily kept. For instance, in order to maintain temporary information such as the number of times of item purchased over the last 3 days, there's this issue that this kind of historical data must be created for each user. Until now, I have explained what real-time targeting is and why it is needed. In this part, I'm going to go into the technical details and explain what log processing platform is. Real-time targeting is built on top of the log processing platform, so I will briefly explain the flow of this part. This is the log processing architecture of the game platform, and I'm going to take you through the actual flow of log processing in detail. The first thing we are going to look at are the game platform services. Currently in the game platform, many platform services are provided. Each service defines the log spec and creates logs according to the format they have set up. For the next step, the logs generated in each service are collected in the Kafka. Kafka is widely used as a distributed event streaming platform. Next part is the storage. The logs that come in through the Kafka go through the preprocessor and then is stored in the storage to be utilized or analyzed for an application. In the game platform, logs are stored in Elasticsearch format for time series analysis or HBase or HDFS format for mass processing. Next, the query engine. Currently, Hive and Impala are mostly used, and in the case of HBase, the Hive's external table function is used for query and analysis. Next part is the processor. In order to analyze and process the accumulated data, Spark or Spring Batch according to the characteristics of applications are used. Next are the data engineering services. Here, functions such as friend recommendation through the virtual graph or targeting are provided, and I will be talking about targeting among these services. Just now, I gave you an overview of the log processing platform architecture. In this part, I'm going to explain how the log processing platform architecture was used to build the real-time targeting platform. First, let me explain how the real-time targeting platform structure looks like. The existing method of updating the targeting platform is as follows. First, the user's profile information is collected and updated. Second, based on that information, the targeting user who fits the conditions is generated in the batch system. For the last part, the users who fit the conditions are provided to the external services through the API. But by adding the event processing here, we built the real-time targeting platform, and I will explain the event processing and targeting in order to talk about the real-time targeting platform. So an overview of the event processing system. In this section, I'm going to explain the overall flow of real-time targeting. This is the overall processing process of event processing. First, log or session and external events come into the source. In case of defined events, they are pushed directly to event queue through the event collector. And in cases of logs and sessions, their suitabilities are first determined, such as whether a certain goal has been achieved or whether the log fits the definition of a specific event. Then when it is determined that it is for the right target, a log or session is changed to suit the event format and collected to the event queue. Then the event manager consumes the accumulated events and stores them in various data storage to be used in analysis. Or the manager pushes the events to services or channels where the event would be put into an actual use. Just now, I provided an explanation using a simple view, and now I will explain the internal structure of the system in more detail. So the game service uses the platform service, and its log is pushed to the Kafka according to the log format. Then the session manager determines whether the data is correct for the session, and if it is, the contents of the session are updated. The event collector checks the status of logs or sessions and generates events. The generated events are published to the Redis stream, and in the event manager, events are delivered through REST hook or channel queue to the services that utilize or collect events. So up to this point, I have talked about an overall architecture or flow. Now I'm going to explain the role of each component and the details of the flow. The components I'm going to talk about are Session Manager. And first, it's about Session Manager. Session Manager is a component located in the source layer, which is used to store status change value or values that accumulate or change over time. For example, it stores whether a user has logged in the last 7 days or the number of times a user purchased items in the last 3 days. And when certain conditions are satisfied, the manager generates a session event and notifies the event collector of an event. So the Session Manager first reads the log and references the definitions for sessions stored in the metastore and checks if any update is necessary. If an update is needed, the manager assigns the values that need to be updated and updates in Redis and HBase. The image is the metadata file of a session. The metadata is saved through the remote configuration server, and filter rules are used to determine whether the log needs a session update. Value rule can be used to define the rule that is updated. Each rule can be defined in the system, and it uses SPEL. For the next part, I'm going to talk about the event collector. Event collector use various sources to filter and validate events and are in charge of creating events. First, the event collector creates an event by directly reading the log or using the data created through the session. At this time, validation checks and values are set, and events are generated also using the remote configuration data. If the rule defined in the metastore was used to judge an event, the data used for the judging process is used to create the event, and the event is pushed to the event stream. This is the metadata of an event. Similarly, validation check and value can be created using the filter rule and value rule. Also, many source types can be added, and currently log and session are supported. Hook is also supported. Hook can be used to receive notifications about events in specific services. Currently, REST API format template is supported. The metadata of this hook is used in the event manager, which I will explain next. An explanation about the event manager. To analyze the event generated, the event manager stores it in the storage or using callback notifies the services of the event. Also, after checking the channel information, it pushes the event to the relevant channel, meaning the Redis stream. The event manager primarily uses the collected event and saves data in a format fit for analyzing. And by referencing the hook template information in the event metastore, the manager notifies the services about the event. Lastly, there's the channel. Channel is a stream for receiving notifications about the scope of a specific game or of a specific topic, and it can be freely created and deleted, and we use the Redis stream, which is convenient to use in a narrow scope stream. Until now, we looked at the components of the event processors. Next, I'm going to explain the targeting platform. The targeting platform. Previously, targeting user was created through batches, but by adding real-time event processor, event information and user profile is combined and targeting user is saved in the storage in real time. Through this, each service provides the service by targeting users in real time or in batches. Next, I'm going to talk about the real-life use cases of what we created. The flow you see here shows an actual flow of real-world application. First, to explain the promotion in this example, it was a promotion that sent away messages to the users who have not logged in for more than 3 months of a reward that will be given. So the admin user creates the relevant condition through the admin tool. The targeting platform judges the conditions of the relevant audiences or collects the users who fit the condition in batches. And using this user data, on push platform, task to send away messages is created. And the sender server uses this task information and sends a request to the Line API server to send away messages. Now, the target user will receive a message containing a deep link, and when they open the deep link, the tracking server will check if the user exists in the targeting platform, and if there is one, reward will be sent. There was an explanation about a use case, and now I will talk about the concerns and technical issues that were raised while developing the real-time targeting platform. This chapter largely deals with 2 cases: dynamic dimension processing and Redis stream adoption. So about dynamic dimension preprocessing. First of all, like most game platforms, many games are operated, and therefore there are many cases where the diverse characteristics of games have to be handled. I'm going to introduce 2 cases with issues related to dimension and their solutions. This is the first issue. So there is game A and game B. Two games use different column keys to save the same information. Currently, the level data uses the column key called level in game A, but LVL in game B. If we save this as is, there is an issue that the same field is saved using different keys. Not only does this increase unnecessary columns, but also when the data has to be used for analyzing or processing, a pre-processing code has to be made for the data each time. This is the second issue. Let's assume that a new game C was added. At this point, Game C saves the level information in the LP column. It also saves the number of item 1 separately. Here, even when item 1 column is not used for analysis, a new column could be added. Similarly, if pre-processing logics have to be added at the code level for new games, it becomes difficult to manage and maintain. In targeting, we solve this problem through remote configuration and SPL. First, there is the profile updater component. In the profile updater, the configuration information determines whether the configuration information needs to be updated by referencing the filter rules. If change is necessary, value rule and ID value is referenced to calculate the value that needs to be actually updated and proceeds with the update in the user profile. Using the simple structure you see here, we were able to do dimension reduction and we were able to make improvements in applying the solution as well. Next is about the metadata. Similarly, the event processor and session manager that I have explained before responds to the menu requirements from the developing companies using the following settings and could be improved to a structure that can be easily changed without deployment. In the next part, I'm going to talk about how we came to adopt the Redis stream in this case. First, a brief introduction of what Redis stream is. Redis stream is a new data structure that was added since Redis 5.0. It can be read using various consumers and it supports consumer group that can control the offset. Also, because it is treated as a data structure, settings provided by Redis such as expire time are available and creation and deletion of stream are relatively easier. Then in the next page, I'm going to talk about why we adopted the Redis stream using examples. Let's consider the following scenario as an example. A request came in from the business team saying that they want to see a user's item purchase history for the last 100 days. Then the engineer can just search the data about one user as a query and send back the result. This is the second scenario. A request comes in from the business team saying that they want to see users' item purchases histories for the last 100 days. In this case, the engineer will have to write a batch application or write queries using Impala, Hive, or others, run it, then send back the results. Next, the third scenario. For the users who purchased items, if they made more than 30 purchases in the last 100 days, we want to give them rewards. Implementing this method becomes a bit more complicated. Usually, we will bucket 100 days of history per user or set fields through aggregation. Next is the last scenario. For the users who purchased items, if they made more than 30 purchases in the last 100 days, we want to give them rewards, but they need to have logged in every single day. Implementing that method becomes even more complicated. In this case, we need to save not only the purchase history, but also the login history. We can find several problems through the previously mentioned scenarios. First, business requirements can change anytime. Continuously developing and deploying the server accordingly will incur great cost in development and maintenance in the long run. Second, maintaining bucketing and window is not as easy as one might think. In order to maintain the buckets of several domains for payment, authentication, and so on, first, the size of the bucket has to be set, and the expired events in the bucket or window has to be consistently deleted and maintained. Last, this is related to the platform service. In order to operate many games, game platform services manage them using a single table format. So changing the schema or creating a table for one game will pose a risk to management and development. In order to solve the problems just mentioned, we adopted the Redis stream. By adopting the Redis stream, creating and deleting streams defined as diverse channels was made possible. Also, game scope streams can also be created, but concern-based stream and user history-based window and other short streams can be maintained. And a user stream created this way can be easily used afterwards in the process of creating context. And because expire time can be set, stream can be expired at certain period or TTL of the stream can be set. Next, I will talk about in what formats event can be managed in the user scope. First, you would receive the channel settings through the event manager, and the event is notified to the user scope stream. The following is a more specific use case. Assuming you want to save a week's login history, in this case, user's login stream is set up separately, and you can specify the expire at. Accordingly, stream data is consistently updated and will automatically expire at the specified time. If a new week starts and gets the stream login event, the stream is initialized and new events are contained to maintain the relevant data relatively easily. Next part is about aggregation update. Let's say you want to update the number of times items were purchased over a week. In that case, you can create the user's current billing stream, and using this information as a reference, the updater can just update the aggregated number. And because the calculation for aggregation is executed by user, recent data can be kept very short. Also, in case of the expire at column, it is mapped to each aggregation field, and this can determine the validity of the corresponding aggregation column. I've used this session to explain the real-time targeting platform. To summarize what I have said in this session, to talk about building a real-time targeting platform, I talked about the introduction and structure of event processing, and for this, I explained the application of remote configuration and the application of the Redis stream to maintain the user's history. I hope this session will help you to use or build real-time targeting. Thank you.